So this one is not a combination of functions, but a composition. So this little circle here is a composition where we're putting one function in as the input of the other function. Another way, let's go ahead with color. We'll use F composite G X. Another way of writing that is that we are taking the F is the outer function, and in that function we're putting G of X. This is, I think, a more open way of doing it. So what we're going to do, we're going to take F as our outside function. So that's this one here. We're going to rewrite X. We're going to put a new symbol for X. So instead of X, we're going to do it as a big open parentheses, because now there's room to plug in. There's room for an input. So rewrite X as a big parenthesis. So we're going to get 4 over X minus 3. Notice as I said X, I wrote a big open parentheses. I have substituted a different symbol for X. But notice this big open parentheses is really ready to receive whatever we need to put there. What is supposed to go there? G of X. What is G of X? It's 5 over X. So that's what we're going to put in here, just like that. So this is our composition of function. All we're going to do is clean it up a little bit with some algebra, because we've got a kind of a complex fraction, a fraction within a fraction, which is like not cool. I don't know, I think it's cool. So let's rewrite this as a single fraction. Let's go with this. So F composite G. What are we working with? 4 over 5 over X minus 3. So what we're going to do is, to get rid of the fraction in the denominator, we will multiply the denominator by X. And so we will think of it as having the denominator having a parenthesis. So this X has to distribute. We have to multiply it here, and we have to multiply it times the 3. Okay. So in the denominator, X divided by X, that's going to be 1. So we're left with 5 minus 3 times X is 3X. But whatever we do to the denominator, we also have to do to the numerator, because what we're really doing is we're multiplying by X over X, which is equal to 1. When we multiply by 1, it's my favorite thing to do, because nothing happens. 1 times 5 is still 5. 1 times 4 is still 4. So, all this stuff. So we aren't changing the number, but we do have to multiply by X in the numerator as well. So we end up with 4X. So this is our composition of function. So let's put that in, and then let's talk a little bit about what we're going to need to do for the domain. It's a little complicated. 4x, 5 minus 3x. So that's our function. For our domain, and again, domains, all we're looking for is we can't have division by 0, can't have a negative inside of a square root. There are no square roots, so we don't have to worry about it. When we're looking at domain, we're worried, we're concerned about what happens in the first step. So the first step is X is going to go into G. So we have to examine that. We're not going to examine what happens in F yet, but what happens in G. And so from this 5 over X implies that this X has to be greater than, or it can't be 0, right? The denominator cannot become 0. I was getting myself a little confused there. X is not equal to 0. So that has to be removed from the domain. We come over to the final product. We don't worry about the intermediate with X. Again, if we plugged in 0 for X, it would become undefined in the first step, right? Right here, it would become undefined. So then what we want to see as well is there a different value of X, that because once we do all this algebra on it, And yes, what we have to look at is 5 minus 3x. Could that become equal to 0? Because then we need to remove that as well. So let's take a look. Subtract 5 from both sides. Negative 3x equals negative 5. Divide by negative 3. Divide by negative 3. So that tells us when x equals, negative divided by negative is positive, 5/3, we're going to have problems as well. So how do we write this? Again, number line, negative infinity, positive infinity. Where are 2 points? One of them is x can't be 0, and I guess what we should say here that x can't be 5/3. So I list these anywhere I want. X can't be 0, so that's going to be an open circle there. 5/3 is positive, so it's bigger than 0 somewhere. 5/3, let's put it there. That's going to be an open circle, but x can be anything else. So it can be up here, it can be in the middle, and it can be down here. So those are the only two values that are not allowed in our domain. So we can start listing our interval. All of this interval from negative infinity to 0, that's good. And then this middle part, which is going to be from 0 to 5/3, it's a little messy, but that is part of our domain. And then we can go from 5/3 all the way to infinity. That's the other part. And what we do is there's 3 pieces. We connect them all with unions. Here it is. Let's go. Where's the union? Okay. So that little u, that's what that's for. Okay, so I'm going to go with this. In this first one, we're going to 2 parentheses, right? And we can go from negative infinity until 0. This one, we're going to go from 0 to 5/3. The parentheses, 0 to 5/3. And then I need one more union. So let's see if I can just do that. Yeah, it worked. 5/3 to infinity. So it's a very sort of complicated way it looks like it, but it excludes those 2 points. Oops, I forgot. I need this. Can I just jump it in? No, I can't. Copy. Let's just see if it works. Yeah, it doesn't. So let's just delete it. Let's put this in here. 5/3. Probably would have been okay if I would have highlighted it first. But anyway, there it is. That is our domain. If you lay things out on the number line, it makes it a lot easier to kind of see all the different pieces. Okay, so that's number 7.